Hey everybody, today we're going to finish chapter 12.2 on independent and dependent events, and our objective is to find conditional probabilities. Alright, so I wanted to talk a little bit more about dependent and independent events before we do make that jump to conditional probabilities. So, picking up from yesterday, we randomly select 3 cards from a 52 card deck. Find the probability that all 3 cards are clubs if you replace each card before selecting the next one. So in other words, find the probability of a club and a club and a club. Alright, so one key phrase here is this phrase right here, if you replace. So this involves replacing the card and means that we're going to have independent events each time. So this is a situation where we have independent events. Anytime you replace a card, you're resetting the probabilities. Alright, so now when you do that, your probability of your club the first time is going to be 13 out of 52. And the second time it's going to be 13 out of 52. And the third time it's going to be 13 out of 52. And when you multiply all those 3 events together, you're going to get approximately 0.0156 or about 1.56%. You can write your answers as a reduced fraction, a decimal, or a percent. It's totally up to you. I would say decimal is my preferred method, but whatever you want is okay. Alright, number 2. Find the probability that all 3 cards are clubs if you do not replace. So if you do not replace, instead of you having independent events each time, you're going to have events that are dependent, where the probability of one event affects the outcome of the other event. So here you're looking at a scenario of dependent events. And this time, the probability of the first card is still 13 out of 52 because there are 13 clubs, 52 cards. But notice the denominator. Each time it's reducing by 1 because you're taking 1 card out. And the numerator reduces by 1 each time because you're taking a spade out. And if you find that decimal, you're going to notice about 1.29%. Remember here it was 1.56%. So there definitely is a difference when you are replacing versus not replacing. You will have sometimes a slight difference in probability, sometimes it's a major difference. It just depends how many objects or items and what it is that you are randomly choosing. So just wanted to cover that one more time, dependent and independent events, and you have a couple problems like this on your homework tonight. All right, now let's move on to conditional probabilities. So here we have what's called a two-way table. All right, there's one category here for defective, non-defective, and then one category here, pass or fail. And a quality control inspector wants to check for defective parts. And we have this table here. So first thing you're going to do before we answer this question is let's get all the totals. And the way we're going to get the totals is we're going to add horizontally and vertically. So you add 3 plus 36 and get 39. You add 450 and 11 and get 461. Then you're going to add vertically. The number down here, keep in mind, should be the same regardless of whether or not you add vertically or horizontally. Should be the same exact number. So for part A, we're going to find the probability that a defective part passes. Okay, so this is called conditional probability. So this is how it would look like written out with the appropriate notation. What is the probability that a part passes given that it is defective? Okay, so in other words, we have a defective part. And we have 39 of these defective parts. What's the probability that a defective part passes? 3 out of 39 will be our answer. 3 out of 39 is the probability that a defective part passes, or again, probability of pass given defective. Be written out like this with a little slash there. All right, the second conditional probability we're going to look at here is what's the probability that a non-defective part fails? Okay, so they're telling us the part is non-defective, and we want to know how many of those non-defective parts fail. That's 11 over 461. So here we're going to say we want the probability that a part fails given that it's non-defective. And that's the probability you're seeing right there. Fails given that it's non-defective. All right, here's the problem I want you guys to try out. So remember to get the totals and then carefully read the question and try to figure out what they're asking for. All right, pause the video and check back for the solution once you're ready. All right, so here, first thing we want to do is add horizontally, then we'll add vertically, and then we'll make sure that this number matches the vertical sum here and the horizontal sum. It should be the same for both. And it is 133,628. Hopefully that's what you got. Part A, we're going to find the probability that a randomly selected collegiate soccer player is female. So of all the collegiate soccer players, there are 73,763 of them. 36,523 are female. If you were writing this in conditional notation, you would say, what's the probability of female given, we'll just say soccer, even though it is collegiate soccer, but we would say female given soccer. Part B, find the probability that a randomly selected male student is a collegiate basketball player. So now we are randomly selecting a male. This is different. So you're selecting a male. There's 69,103 males. How many of those males are college basketball players? 31,863 divided by 69,103. And that's 0.461. So in the probability notation, you would say probability of basketball given male. Basketball given that they're male. And if you flip this around and say male given basketball, that's a whole different calculation. Then you're looking at all the basketball players. There's 59,865 of them. And then you're taking the males divided by that number, which will change the denominator on you. So be very careful. Read the sentence very, very carefully. All right, here's one more to practice. These are not too difficult, but a little bit of practice and you really see how they work. Pause the video again, try it out, check back for the solution once you're ready. All right, so here we're going to get the totals. Fill those totals up. There's 245 on the bottom. Find the probability that a randomly selected ninth grader, so you're selecting a ninth grader at random. There's 120 of them. How many are in band? 57 out of 120. That's the probability of band given ninth grade. Down here, the probability that a randomly selected chorus student is a 10th grader. So now you're looking at all those students that are in chorus. There's 140 of them. And 77 of them are in 10th grade. So these can be tricky. Like I said, read it very carefully. Try to find out what condition is given. The second problem, it's contingent upon them being in the chorus. First part, they've got to be in ninth grade. So that's your conditional probability. All right, so we actually have a rule for conditional probability. Now, you don't have to use this, but it's going to be helpful for the next few problems that you see. So this is one of the formulas we looked at yesterday. And what we're going to do is we're going to solve for this conditional part of this equation. We're going to just solve for that value right there. That's easily done by just dividing both sides by probability of A. You divide both sides by the same quantity. Remember, that's totally fine in any equation. That cancels out. And this probability right here is equal to the probability of A and B divided by the probability of A. So let's try this out. So here, at a school, 60% of students buy a school lunch. Only 10% of students buy lunch and dessert. Notice lunch appears here and here. And in the second sentence, they have the word and, so they're grouping lunch with dessert. All right, so there's an and probability here, and then there's just a probability of lunch by itself. What is the probability that a student who buys lunch also buys dessert? Here's how you would word that out in the conditional notation. What's the probability of dessert given that the student buys lunch? So let's define our events here. Let event A be that the student bought lunch. Let event B be that the student bought dessert. And remember, A and B together is lunch and dessert. Lunch and dessert. So I'm going to take out that trusty equation here that we just figured out. Probability of B given A is equal to the probability of A and B. Probability of lunch and dessert, which we know is 10%. So 0.10 goes on the top, divided by the probability of just lunch. And we know that that's 60%. So now we take 0.10 divided by 0.60, and you get approximately 0.167. All right, let's try out one more of these problems here, just like this. At a high school football game, 80% of the spectators buy a beverage at the concession stand. So, beverage, 80%. 20% buy both a beverage, that word, there goes that event again, but this time it's paired with food item. What is the probability that a spectator who buys a beverage also buys a food item? In other words, what's the probability of food item given beverage? Please pause the video, give it a try, and check back once you're ready for the solution. All right, so all you need to do here is take 0.20 divided by 0.80, and you get 25%, or 0.25. All right, that's going to be it for us for today. Have a great day, everyone.